Okay, so just before we start our next section on 5.3, where we're putting h and k in, remember that cos and sine look almost identical, but sine starts at 0, whereas cos starts at 1. Notice though that in this one, you guys, I put degrees on the x-axis. We see that? You can have degrees or radians on the x-axis. The process stays the same. So here, the period would be 360 degrees. But remember that 360 degrees is 2 pi radians. So that's why either degrees or radians, can be your x-axis. I have one here of tan as well. Same thing. This one here is 180 degrees is the period. Remember that you have asymptotes at 90 and 270, and then your graph hugs your asymptotes. So it's so important that you remember what your original graphs look like before getting into this stuff. So here we're getting into A, B, H, and K. So please write this down. So again, this is your A, your B, your H, and your K. You should have a pretty good idea of what they mean by this point. Let's look then at a little bit in terms of sine, cosine, and tan. So A affects the amplitude. And remember that the amplitude is actually the absolute value of A, because the amplitude value is always positive. It's talking about a distance. So even if your A is -3, your amplitude is +3. The period is found by 2 pi divided by B, or we could say 360 degrees divided by B. So it's your regular period divided by your B for your stretch. In tangent, the A still affects the amplitude, but you have to be a little bit careful here, and I'm saying this kind of vague. The amplitude meaning the height of the graph. So A still makes it taller or shorter, but what is the actual amplitude of a tan graph?
Undefined.
Right, but the amplitude is undefined for a tan graph, but again, A still affects the height of it in how it's stretched. The period for tan is found by pi over B, or we could say 180 degrees divided by B. So when we're drawing our graph, we start with an original table of values. Now here I have an h value of -pi/6. Be careful of your signs. Remember that with h, the sign is different. And our k value is going to be -2. So that means my whole graph is moving pi/6 units to the left and 2 units down. When I set this up in mapping, we get x minus pi/6 and y minus 2, because it's your h and your k. From there, we're just going to plug our values in and draw our graph. Now, when we're graphing this, I'd like you to notice that our points all have denominators of 6. So the easiest way to graph this is to let every little square on your grid be a pi/6. So I'd start here on this side at -1 pi/6. And then my next x value is 2 pi/6. And then I have 5 pi/6. So this is 2 pi/6. This is 5 pi/6, -pi/6. After 5 pi/6, we went to 8 pi/6. And then we had 11 pi/6. So again, if you think of each little grid as a pi/6, then this stuff is pretty easy to count. Now my graph is at -pi/6 and -2. Go down by 2's there. So -pi/6 and -2. Then we're at 2 pi/6 and -1, 5 pi/6 and -2, 8 pi/6 and -3, and 11 pi/6 and -2. So you have that curvy graph, something like that. So for this next graph, we have an A, a B, an H, and a K. Our B value is only 1, so there's going to be no period stretch. When I plug this into mapping, we're going to get x divided by b, so we can just say x, minus pi, and then a is half times y minus 2. And then we're going to plug in our points from our original cosine graph. Okay, so once you've got your points, again, they follow that pattern. We're starting at minus pi and minus 1.5, then we go to minus pi/2 and minus 2, then we go to 0 and minus 2.5, then pi/2 and minus 2, and pi and minus 1.5. So it's going to make a shorter cosine graph that moved pi units to the left and 2 units down. From here we can find our amplitude and our period. So your amplitude should be half and your period should be 2 pi. Let's take a look then at a tan graph. So we have to start with our original tan graph. And one other little thing to remember here is that your b value has to come out of your brackets, which changes your h to a 3 pi over 4. So we have all a, b, h, and k. We need to plug this into mapping. So since all of my denominators are over 8, we're going to make each one of these little squares a pi over 8. So my first one's at 6 pi over 8. So that's 6 pi over 8 right there. And 7, 8, 9 pi over 8 is the next one. 12 pi over 8. 15 pi over 8. And 18 pi over 8. And we're going all the way up to 1.5. So I'm going to say that this is 1.5, 1.5. So from here, asymptote should be the easiest one to put in. The asymptote is at 12 pi over 8. So I'm going to make 12 pi over 8 my asymptote. My first point was at 6 pi over 8 and 1. Then I had a point at 9 pi over 8 and 1.5. I had 15 pi over 8 and half. And 18 pi over 8 and 1. So your graph is going to hug your asymptote in both directions. At a graph like this, we can find our amplitude. But be careful, the amplitude of a tan graph is undefined. The period is pi over b. And in this case, b is 2/3. So pi over 2/3, which is really 3 pi over 2 when you multiply by the reciprocal, or when you flip the 2/3 and multiply.
That would be 6 pi over 8.
So that's the period.